All right, good morning, everybody, or maybe afternoon or evening, if that's when you're watching this. Hope you were able to manage the lesson yesterday on the balancing equations review. That is, I can't stress it enough, that's a very important skill in chemistry as we move forward. Most of what we do coming up in the next few weeks or month or whatever really needs to have that skill of being able to balance chemical equations to do that, to do the next concepts well. So if you are still really struggling with balancing chemical equations, you need to let me know, and we can work some time where we can work together. One of the advantages of e-learning now is that it gives teacher and student maybe a little more opportunity to work one-on-one than we would if we were in a regular classroom setting. So if you need some extra help on balancing chemical equations, if what was you did yesterday very, very difficult yet and you don't understand it, please send me a message and we can arrange a time. And it may only take 10 or 15 minutes to kind of go through a couple things and then you'll get it. Okay? So let me know if you're still struggling with that. So today's lesson is a lab, and that's why I'm here in the lab. We are doing this lesson, which is taking a look at the different types of chemical reactions. We introduced this before spring break. We realized there were 5 different classifications, and they're on page 2. So if you want to open that up on your Chromebook, have that handy, that would be very helpful today, because that's part of what we're going to do today. We're going to take a look at some chemical equations or chemical reactions and try and identify which of the categories they belong in. So if you remember, the categories were combination, where 2 elements get put together to make one compound, or the opposite, which is decomposition, where one compound splits apart into 2, and then the 2 displacement or exchange reactions, where you might have a single exchange of elements, or maybe you have a double exchange, where 2 sets of ions switch places. And then the 5th category is the combustion reactions, where hydrocarbons, carbon-hydrogen compounds burn with oxygen in the air, and they're producing carbon dioxide and water. So these are the things we're going to take a look at today as we go through our different chemical reactions. So one thing I'd like to help you review a little bit, and it's found on the front page in this first introductory paragraph, are the signs of a chemical reaction. We did a lab a couple of weeks ago where we looked at whether things were going to be a chemical change or a physical change. If you remember, there were 4 different signs that typically indicate that we have a chemical change. So do you remember what those are? Well, let's see if we can write them down here. I would use my whiteboard, but it's in the other room. I do have a smaller whiteboard here, but I've already got stuff on that for later in the lesson. So I'm just going to write it down on my sheet of paper here. So one of the chemical change, or one of the signs of a chemical reaction, typically is a color change. Okay, a change in color. Many times that indicates that we've had a chemical reaction. Another one is producing a gas. And that a lot of times is evident because we have bubbles occurring in our test tube, or maybe we'll smell an odor of a gas that we didn't have before. Okay, so that's a pretty good indication of a chemical reaction. Third one is producing a solid that was not present before, and that's something we call a precipitate. Remember that word, a precipitate? It's a new solid that we didn't have before. Typically this happens when you have 2 chemicals that are solutions and you mix them together, and then out comes a solid that's no longer soluble in the solution, so it precipitates as a solid, and we start to see that. Okay? And then the 4th one is a change in energy. Maybe the substance gets hot, maybe it gets cold, okay? Or maybe there's some light being produced, or sometimes even sound. Sound's a form of energy as well. And so that'll be another one of those reactions. So most chemical reactions will have at least one of those, and to be honest, most chemical reactions have 2 or 3 of these occurring all at once. So we will use these to help us identify if we have a chemical reaction today. Okay? All right, so our first step is to find our data table. And in Google Classroom, you'll notice that this lab is posted as one of the documents. But then I also posted 2 other documents that you will need to open up. Our data table page, okay? And this you can do one of 2 ways. If you're able to print this, go ahead and do that. That's probably easiest. If you don't have access to a printer, then just make a data table on some notebook paper using these columns. So if you need to do that, pause the video right now and get your data table set up. If you want to go print it, go do that. If you need to use a notebook paper, you can do that too. So there's basically a couple of columns here. One is just a column for the number of the reaction. We're doing 8 different reactions today. And then the second column, you're indicating 3 things. You're going to describe the appearance of the reactants. What do the reactants look like before we start? And then you're going to describe the appearance of the products. What do the products look like? And then we're going to try and identify what is the evidence of our chemical reaction. Did we get a color change? Did we get energy being produced? A gas? Those 4 signs are going to be critical. So that's what we'll put down on our data table. Okay? The second page of that is something we'll do afterwards. This is where we'll write our balanced equations. And then the second part there is a little more practice in doing that. So that we'll do a little bit later. But for right now, you need this data table or a notebook paper that you can put this data table on. All right? The other page that's there is this page. Talks about properties of chemical reactions that involve gases. I'll refer to this mainly verbally, but if you need to go back and take a look at it a little closer, it's there. But for the most part, I'll just kind of describe this aspect as we go along because it describes some of the things that we can test different gases for, because for the most part, many gases that are produced all look the same. They look like something's bubbling. But to tell whether it's carbon dioxide gas or hydrogen gas or oxygen gas or ammonia requires some of these other tests, and this is what we'll be doing as well too. All right, so let's get started. You've got your data table handy, and what's going to happen is I'm going to do the chemical reactions. I'll try and show them so that you can visibly see what's happening and write down your data, and then we'll work on balancing our reactions and trying to come up with what the products are. So let me grab my safety goggles. Always got to be prepared for safety here, so I've got my safety goggles on. I've also got over here on the side whiteboard. These are going to be the chemical reactions that we're going to do, and we will eventually identify what the products are going to be. All right, so our first chemical reaction is magnesium. So you can put that down in your data table. The reactant is magnesium, and we'll get that out and show you what that looks like. This is actually a reaction you did in the lab a couple of weeks ago when we were looking at chemical and physical changes. Remember, magnesium is this silvery piece of metal, right? So that you can put down in your data table that the appearance of magnesium as a reactant is kind of a silver piece of metal. And then what we're going to do is we are going to heat it up by using the flame of a Bunsen burner, right? It produces a very, very bright light, right? Remember doing that? And then afterwards, it no longer looks silver. It may be kind of hard to tell here, so let me put it in an evaporating dish, and we'll notice that it's very powdery right now. It's very white in color and powdery, okay? So we've got a couple of signs of a chemical change here. We've got a color change, went from silver to white, and the solid, it's not the same solid. It's not that piece of metal I had before. It's very crumbly and powdery. So I've got that as evidence too. And my third piece of evidence, what do you think that is? Which of those 4 signs did we see? We saw a color change. We see a new solid. You might not have seen evidence of a gas, but maybe you did. Did you see smoke coming off? That's a new gas. And the other one is a light form of energy. So we actually have all 4 chemical signs there in this particular chemical reaction. Okay? So I'll write down some descriptions of the product, write down which of the 4 signs we had, because we actually had all 4. We had a color change, we saw energy, light, we saw evidence of a gas, some smoke, and we've got evidence of a new solid. So on our reaction then, and this is something that you would do on page 2 of the sheet where it says post-lab questions, write out the chemical reaction. We're going to kind of do this together as we do the reactions, so we can kind of make that connection between the two. So magnesium, I put it in the Bunsen burner flame. Now, Bunsen burner flame is not an element. It's a source of energy, heat. But if it did start to, quote, catch on fire, there weren't really real flames there, but it did react with some oxygen in the air. So I'm going to put down O2 as my other reactant that I was reacting with. Okay? So what kind of a reaction do you think this is? If you need, go back to your 5 chemical reaction types. This page here illustrates them pretty easily. Okay, which of these types do you think it is? Maybe pause the video, think about it for a couple seconds, and then come back. In the case here, I have an element reacting with an element. So which of these types is most similar to that? And if you look carefully, I think I agree that it's very similar to the combination, where you have an element plus an element forming a compound. So now we have to come up with what compound is being formed. Okay? So I've got magnesium and oxygen reacting together. Now some of you may ask, well, why did you not put the 2 over there? Well, when I write a compound, I have to identify the charge of those 2 ions. And this is where I would go back to my periodic table, the yellow sheets, right? And look up the charge of the 2 ions. Now, just to kind of save a little bit of time, I'm just going to kind of tell you what those charges are, but you could always verify that going back to a periodic table. Magnesium is in column 2, so it has a +2 charge. Oxygen's over on the right side of the periodic table. It's in column 6. It has a -2 charge. So I have a +2 charge and a -2 charge. Those charges balance, so I don't need any subscripts. However, I do need some coefficients, because oxygen as an element is a diatomic element. That means it has to occur in pairs. So to balance this equation, what kind of coefficients would I use? You should be able to do this. All right? So if I've got 2 O's here, I only have 1 O here. I need to have a coefficient 2 in front, so I have 2 O's, right? But that also means I have 2 Mg's. So now I need to have 2 Mg's and put a coefficient 2 on that side. And I've got a balanced equation then for my first reaction. Okay? And this was a combination reaction. All right, so let's go on to reaction number 2. We'll keep these moving here so we're not using up too much of our time. So I've got magnesium again. Take a test tube here. I'll put a strip of magnesium in it. And my second reaction is magnesium reacting with hydrochloric acid. I think we also did this one the other day in that other lab, except I think we probably used zinc instead of magnesium. I don't remember for sure, but here's my hydrochloric acid. So I will add some here, and if you notice, you should be able to see it, there's some bubbles, right? Evidence of a gas coming off. Some bubbles as the magnesium reacts with the hydrochloric acid. So we have evidence of a gas, right? We can see that. If I feel the test tube, yeah, it's getting kind of warm. So I've got evidence of a energy change there. So I have those 2 products. Okay. So initially my reactants, you had what the magnesium